Hello mga kachimek. So we're down to the last two topics on the gas laws, particularly the last two topics for the semester, na the Avogadro's law and the ideal gas equation. Before that, let's have a quick recap of what we have learned for the past sessions about gas laws. So during the first discussion, we learned about the difference or the relationship between the pressure and volume, where we learned that the pressure and volume are inversely proportional. What do we mean by inversely proportional? It simply means that as we increase the pressure, the volume decreases. Vice versa, if we increase the volume, the pressure decreases. They have inverse proportionality. And this has been accounted in the Boyle's law through this formula at constant temperature and constant number of amount of gas rather. So that's constant T and constant N. No? N stands for the mole or the amount of gas. And we also learned in the Charles law or Charles's law, Charles's law, the relationship between, that's right, volume and temperature. So V1 T1 is equals to V2 T2. This is at constant pressure, constant number of gas. Again, we don't change the amount of gas in our specific container. And then, lastly, we've learned about the Gay-Lussac's law. It's the relationship between the pressure and temperature. So, for both Charles and Gay-Lussac, volume and temperature are directly proportional, meaning kapag ininit mo, lolobo, kapag pinalamig mo, mag-shrink. That's the relationship of volume and temperature, so that you will not forget. Now, as we increase the volume, the temperature, the volume also increases. Now, as we decrease the temperature, the volume decreases as well. Pares lang naman yan kapag binigyan mo ng much space, it will become cooler, so the temperature will go down. Either way, they're both affected by each other. Gay-Lussac's naman, if you increase the temperature, pressure increases, decreasing the temperature, the pressure decreases. This is at constant, very good, volume and number of moles. And then eventually, we learned that these three different equations crafted by three different scientists are actually talking about the same thing, the behavior of a gas. Now, these are created or rather written in an equation by three different scientists in three different times, of course, along with the conspiracy, along with their core researches, along with anyone. Basta these equations were named after them. So eventually, it was realized that it can be combined into a PVT, P2, V2, T2. And this was our combined gas law. So this become our combined gas law. And at constant number of moles, or at constant amount of gas. So, akala ng mga scientists, just like the planetary model of Bohr, this is the final equation for the gases. But notice that we still have a constant, In the scientific world, we want to get rid of the constant because we are simply talking here about an ideal situation, that the amount of gas will not be changed. But what if we change the amount of gas? So people started asking, maybe we can put the equation, or we can create an equation where the number of moles or the amount of gas could be changed anytime without destroying the magnificence of the combined gas law. So here comes the famous Avogadro Amadeo Avogadro. He has a very long name. It's Lorenzo something something Amadeo Avogadro. His account, no, and also a scientist in his time. So Avogadro simply proposed the relationship, no, because he was famous of creating or discovering the number of moles. If you remember the Avogadro's number, where it's 6.23 times 6.22 times 10 raised to 23. You can remember that. That's the number of something, no? Meaning 1 mole is equivalent to 6.02 rather. 6.02 times 10 raised to 23 of something. But if you can recall, if I have 12 dozen eggs, if I have 1 dozen egg, meaning I have 12 eggs. If I have 1 dozen of donut, I have 12 donuts. Eventually, if I have 1 mole of donut, I have 6.02. All right, my inks are not working. I have 6.02 times 10 raised to 23. No, meaning that I have a plenty of donut. That is our 1 mole. So, Avogadro simply says that gases, since they are too many, they are too small and too many, we can account them in terms of moles. Kasi we have already discussed the grams per mole, the molecular mass, molar mass. So, we can simply use them. Avogadro simply states the relationship between volume and the amount of gas. No, so imagine a balloon. No, do not think of anything else that's a balloon. So if I increase the amount of gas inside the balloon, dadagdagan ko ng hangin yung balloon, what would happen? No, of course, the balloon will increase. No, the volume of the balloon would relatively increase as I increase the amount of gas inside. If I decrease the amount of gas, the volume, of course, would decrease. And that relationship is directly proportional, or direct relationship. They are directly proportional. So meaning, as I increase the volume, the number of gas inside will increase, no? That's one way or another. If I decrease the amount of gas inside, obviously the volume would decrease. So how do we illustrate that in an equation for Avogadro's law? So Avogadro's law looks like this one. Avogadro's law is simply Vn, no, is equals to a constant. At constant, of course, pressure and temperature. Or we can rewrite that as V1, as we usually do N1, is equals to V2 over N2 at constant pressure and at constant temperature. So that is your Avogadro's law. Now, how do we put it into reality or put it into an equation? Very simple. If I have a basketball like that, a basketball, a molten ball there. The initial volume of that ball is, let's say, 2.5 liters. And inside the gas is 1.3 mole of, say for instance, combination of gas. It doesn't really matter as long as I know the number of moles. Now, I want to increase the amount of gas rather by adding 0.7 moles. No? Therefore, it becomes 2.0 moles of gas. It becomes 2.0 mole. What would be the final volume of my basketball ball? Basketball ball. Yeah, I think that's the right term, or simply basketball, but it's the game. So this becomes my N1, this becomes my N2, This becomes my V1. This becomes my V2. So question, what is my final volume? So using the equation, that's V1 N1 is equals to V2 over N2. I'm looking for the V2. So I multiply both sides by N1, N2. Again, this is your cross multiplication. You can simply cross multiplication. But I'm doing the right math, the multiplicative inverse, N1, N2. Cancel, 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 cancel. I'll be left with V1, N2 equals to V2, N1. Divide by both sides by N1, N1. Then I have V1, N2 over N1 is equals to V2. Now, I input that into the calculator, my values. Remember, the units should always be liters for volume, mole for the N. So, that would be V1 times N2, 2.0 times 2.5. That would give me 5 divided by 1.3. And there you have it, 3.84 or 3.85 or simply 3.8. So you have two significant figures. So V2, alright, I'm out of ink, is equals to 3.8. And the unit is liters because the liters will remain, moles will cancel out. Alright? Hopefully you got it. That's 3.8 liters. Let's check. We increase the number of moles or the amount of gas. Therefore, the expected volume would also increase. That's 3.8 liters. Now, let's have one last example. Right. One last example for our Avogadro's law. Now, what if the problem goes like this one? I have 50 grams. Alright. Please bear with me, my beloved inks. Alright. I have 50.0 grams of oxygen gas. So, O2 gas. And it gives me, say for instance, ano kaya? Hypothetical example lang to. I don't know if this is accurate. So, it gives me 3.5. Right, my inks are not working. 3.5 liters. Ubus na, wag naman ngayon. 3.5 liters. The initial container is 3.5 liters. Now, the initial volume of a 50.0 grams of oxygen is 3.5 liters. Suddenly, the volume increased in 5.0 liters. Now, it becomes 5.0 liter from 3.5 liters. Now, what is the final amount of gas? Now, what is N2? Now, question. Can I solve this? No, it becomes a bit confusing, a bit difficult, and a bit challenging, especially you're looking at grams, no? Minsan nakakatakot pag ganito, pag naka-grams. Diba? Mas madali kapag given na yung mga proper unit like moles and so on and so forth. So, first, to attack the problem that seems to be very difficult, let's label them. First, this is your V1. It's your V1, right? This is your V2. My ink is almost out. So, 3.5, 5.0. I'm looking for my N2. And this is supposedly my N1. No, this is my N1. But it's not in mole. Now, how can I get the value or the needed value of moles for this one. So, I learned in the past lesson, no, if you still remember, that oxygen has a molar mass, no, it is 32 grams per mole. So, 32 grams per mole. So, maybe I can use this to get the mole since I have 50 grams of oxygen. I have 16 rather, 16. But since O2 siya, dalawang atoms ng oxygen, so that becomes 32 grams. You feel me? You get it? Na 32 grams kasi dalawang oxygen. Oxygen is diatomic, so it will always come in pair. 32 grams. So, to cancel this one, that would be, or to get the mole rather, I can just use 50 grams, 50.0 grams times 1 mole of oxygen and the 32 grams. Cancel. I interchange the grams per mole because I'm looking for the mole. No, you can simply do that by, you can also use 1 over 50 grams if you don't want to interchange. So that would be 50 divided by 32. That is 1.5. Now, as simple as that, as long as you have your periodic table and you know the molar mass, 1.5 or 1.6. Now, let's use 1.6. 1.6 moles. This is 50.0, so 32 is two significant figures. That is your N1. Now, I have my N1. What I need to do is to manipulate the equation. So, can I erase this first? Remember 3.5, 5.0. 3.5 and 5.0. It would be V1, N1 is equals to V2, N2. By the way, sorry kung minsan naggagalaw-galaw ang camera. I'm using my left hand to hold it kasi nasira yung tripod. Anyways, so I'm looking for my N2. Cross multiply, that becomes V1, N2, and then V2, N1. I'm looking for N2, so I divide both sides by V1. That remains N2 is equals to V2, N1, V1. Input the necessary values. My volume 2 is 5.0 liters. My N1 is 1.6 mole. And my initial volume is 3.5 liters. Liters will cancel out. Right? So let's put that into calculator. 5 times 1.6, 8 divided by 3.5, that would be 2.29. Two significant figures, so that would be 2.3. So 2.3 moles is my N2. So I increase the volume, therefore the number of moles should increase as well. Definitely increase. N2. That's 2.3 mole. So that's your Avogadro's number. Thank you so much for listening. Now for your problem, again, for the problems that I am giving you, since this is formative, it's either you comment it in the YouTube or you send me a private comment. It doesn't really matter, or you don't do at all. It's fine because it's formative. But if I ask an activity, like the electron configuration, you are required to turn it in. So say for instance, I have a lithium gas, 35 grams. Sige, I'm sorry, my inks are no longer working. So I have 35 grams. Yeah. Hopefully this will do. Sige, 35 35 grams of lithium gas, or helium gas rather. Helium gas. And yan, the initial volume, so V1 is 2.5 liters. 2.5 liters. And then the final amount of gas suddenly became 3 moles, 3.0 moles. What is the final volume of the helium gas? Or this is N2. What is the final volume of this gas? So kindly solve. 35 grams of helium. And then, the initial volume is 2.5 liters. The final amount of gas from 35 grams helium becomes 3.0 mole. What is the final volume? Again, comment sa YouTube. Send me a private comment. It's okay. Anything. As long as you try solving this one. And then, again, we still have our handout. May detailed way of solving doon. Mga 3 examples, I think. So that you'll learn. And again, this is just a supplementary video. So if you don't understand by watching this video, you can watch other videos. Thank you and have a great day.